Hello and welcome back to building a computer in Minecraft. In the last episode, we talked about the multiplexer, and today, we're gonna talk about something else. It is, very amazing, okay? But first, I'd like to tell you some things about what has gone into this project so far. 1.32 days and over 14,000 pieces of redstone dust have led us to this finished computer. Yes, you heard me, it is finished. It has all the things it needs to be finished. So I'll go ahead and show you all this map I made of it, because that is the coolest way of showing it off. Alright, so here we go. We got, okay, so the things we needed were registers. We have those now. We needed a control unit, which is over here. And, we also needed buses. So I have buses hooked up to the multiplexers. I have buses that will take and propagate our binary numbers. And then I also have buses for when it overflows that will switch it from mathematics to logic. So that will hopefully fix the overflow problem and allow it to propagate numbers. So what exactly does my computer do? Well, simply put it, you put in some inputs. You can put in up to, we'll get to that in a second. But you put in some inputs, you get out a few outputs, you get a 4-bit number as the outputs, but I've converted that by storing the last 4 4-bit, outputs in a register. I can take the register outputs and use those as the new 16-bit numbers, which propagates the numbers. It changes them a little bit, and then puts them back in. Unfortunately, it's not automatic. You still have to press one button to get the thing to go, but after you've programmed it, you can reset it, you can do all that cool stuff, and I'll show you all of that in a second. But first, we need to talk about the registers, because those are my favorite part of the whole thing. These guys. So, let's go ahead and talk about them. So these registers can hold, each of these two can hold up to 8 bits. Yeah, in each row there's 8 bits, okay? But in each column, there's 8 sets of 8 bits. So there's a total of 64 bits being stored in each of these. And this is all ready to run a code. So when I press this button, it's going to shift the bits forwards a bit. And that's how I store 8 codes, or commands, or whatever you want to say they are. Which allows us to flip them forward, and boom. And I haven't actually tested this thing yet, so I don't know if the control circuits are actually going to fire. But as you can see here, these are the control toggles for the multiplexer. We got one here, one here. This one is currently running the AND/NAND minor, which is like the lower AND/NAND. This is AND/NAND major. It's currently running. Then, if there's an overflow, these both have to turn on in order for it to switch to logic. But if one of these turns on, it will switch the this thing. So it'll switch which mathematic units it's using. And then lastly, I didn't really know what I was gonna do with all the numbers when I was done, and how I was gonna visualize it. But basically, this system here visualizes it pretty well, I think. I mean, you can look at it from the bottom and you will kind of be able to see what is going in and out. But this all is taken from the, here. So eventually, there won't be any inputs in there, I'm pretty sure. I don't know. It depends on what you put in, and if you put something in, it does something with it. And the major problem with this computer is that it actually takes so long for the numbers to get back to here because of how big I made the thing. I shouldn't have made it so big, I should have made it smaller, but it would have been, this is my first time. So I didn't really know that when I was going into it, but it's kind of not synced, so you have to wait a second before you press the button, for like a few seconds. So we have to wait for it to go through. It's gonna take a very long time for it to get back. Now, if you wanted to reset this thing, all you have to do is you have to flip these off and then press the button 8 times to reset this register. Which also won't reset the register over here, but the way you would reset this one is by firing this section of repeaters over here, this one. So you'd have to put a button here and just like fire it a few times, or like, oh wait a second, this one isn't even part of the circuit anymore. Look at that, I caught a mistake I made. Ha. Now, when I was building that last register, I ran into a bit of a problem, and I didn't know which output to use, and I was going to do it a different way, so I came up with a new logic gate on accident. So this logic gate represents the converse non-implication, according to Wikipedia. I don't know if this is... yeah, but okay. I'll go ahead and demonstrate with some levers instead of redstone torches, but... Okay, so in the converse non-implication, if both are true, it should be off. So, both are off, it's also off. Okay, cool. But when both are true, it's off, as you can see. Then when one of them, which is probably, I think that's A. So if A is on, this is going to be on. So if we fire, I believe this one is A. So if we fire that one, it's on. But when we switch this one on, it's going to be off. Then if we fire this one on, it's going to also be off. So this is actually converse non-implication on accident. Actually, what? Why is it doing that? It should not be doing that. It should be more like this. So, boom. It's always off. Every once in a while... Oh crap, I just messed this up. I've probably just purged the whole system. I probably need to reset the... Yeah, I think everything is the same now. Yeah, I just messed everything up. Whoops. Yeah, that's fine. Maybe it's best left to the user to press the button. So, that's fine. We'll just press the button a few times and see what happens. I don't think it's actually gonna switch anything. I think we need to reset. Alright, so I flipped the read switch, which is also the reset switch. And all I have to do is press this one. So it shifts over and we'll erase a row. For some reason, these guys are still coming through. 2, 3. I have to... Oh, crap. Maybe I should start at the other side. That's probably the problem. Alright, so we'll start over here and start resetting this one. This one is going to be quicker to reset because this is only 4 bits. As you can see, those are actually moving. Oh, yes. Yes, it's just like what I want to see when these things are being reset to how they should be by default. Well, actually, not really. But, this is how the control circuit wants it to be. So that's how it's going to be. And I believe it's reset now, so... Now, once that's reset, you can actually come over here, and I have buttons over here for you all that you could press to switch this to how you want it to be. Because if you set this one on by default, then it will switch off when that one turns on. So it's pretty cool. You can do some pretty cool stuff with this system. It's pretty configurable too. Yes, there was also a torch jamming the system from when I was testing. Apparently I didn't clean up well enough. Okay, let's go ahead and fire this again. Why? Wait a second. Why is that one on? Let me just follow this bus all the way back to where it goes. Are you kidding me? There's another testing torch? Why? Alright, so I have just fully finished unprogramming this thing. It's fully reset. Full reset on everything. I think even this level is reset as well. Now you can check by going over and looking and seeing if any of these repeaters that are locked are still on. If they are locked and they're still on, that means you've saved something. And you probably don't want to save anything. So let's start off with a good program. I'm gonna go ahead and run this, and we'll see what happens when we propagate one of these programs at a time. All right, so we'll do a bit of we'll overload both of these gates. Why is this one on? That's been on the whole time. I need to go back and check on this. What is this one doing? Okay, so somewhere over here, this one is the one that's on. It's being powered by what exactly is powering this? Is it another testing torch? Are you joking me? How many testing? Oh, it is a testing torch. I can see the testing torch. I can't get out of here because all this. I mean, that's fine. I'll just have to reset it again. Okay, so I want to overflow both of these because that will cause the overflow to happen, and will switch us to logic. So that's how you switch the logic, is just by causing an overflow in the adders, both of them at once. Then we'll go ahead and throw in some of these. I think that looks pretty good. We'll go ahead and press the button like 1, and we'll just write another program if you want. You can write as many programs if you want, and if you only want to write like 2 or 3, then you write 3, and then you would press the button like, I would say 8 times to actually run it. No, not 8 times. That would full reset, but like you can figure out what I mean. You press it until it runs. So yeah, I'm gonna leave it overflowed for now, and then like once we get propagation from the system, we'll go ahead and do all that stuff. We'll switch those 2 off. We'll also run a few carry-in additions, so we'll have both the A and the B on for these, and I think this one could also be A and B, which will carry over. So that will be 1, that will be 1, that will carry over to here, which might cause both of those to be 1, which might cause an extra overflow. Which I don't know what happens when you cause 3 overflows, but hey, it's gonna do something interesting. Probably just the same thing as it's already doing right now. You know, we'll switch out the overflow, so we'll have this be overflowing like that way. That might cause something interesting to happen, because that'll switch the gates that we're using for the overflow. Boom, we'll press that button again, and now I think we're ready to go. I think we've got enough programs in there. So yeah, the more bits you add in, the more scrambled and more interesting it's gonna be, from what I understand, or from what I've came up with. I'm assuming this is how it's gonna be for the system, because, you know, the more bits, the more things it's gonna be doing, and then the more it's gonna process back into here as a different thing, because of all these things doing something. So now I'm gonna try to find where the first bit is at, and which column it is in. So there's that, okay, that one's got a bit in it, and then this one has 2 bits on the very end. Okay, this one, so we're 1 short from what we need, but that's fine. I can fire it with 7 bits in there, and it should still propagate some interesting numbers. Of course, I do believe that if it has 4 off, that might cause some interesting things to happen, so we'll go ahead and fire it one last time. Is this one on? Okay, we need to switch on the read command, which will now fire the rest of the system. So boom, reading now, and as we can see, we should be getting some outputs into the register over here. Now, we do need to fire it like 4 times for this to actually switch over, but that's gonna be pretty interesting. Oh, are we getting something in? We getting something now? Okay, so that's not gonna actually do anything, but that would switch the... No, it's not actually switching. So the top layer has not written the code properly. No, it's just not saved. What the heck? What the heck is this? So, the bottom one does have some data on it, but the top one does not have some data on it. So I think we might have some problems here, but this should be pretty easy to fix and pretty easy to just press the button again. We'll just see what happens now. Alright, so we do got some bits going in, and we'll go ahead and check over at the register. Now you can see we've saved 1 bit at the register, which, is this a logic gate, or... Okay, it is not a logic gate, it is, in fact... Okay, we've saved 2 bits, actually. There should be 2 bits in here. Unfortunately, it has not saved 2 bits. It's, not done anything with those. Why is this one not being saved to the system? It should be saved into the system. Maybe this is new. So that might have been the last operation we had 1 bit in there. So maybe if we press the button again, something's gonna happen. Alright, so it should now be throwing a bit into the system. We'll see if those last 2 bits were saved into the system now. And they appear to not have been saved. They just appear to have been erased. So for some reason, this system is not actually firing when it's supposed to. So we'll just do that automatically, which should shift the bit over and save the current bit. Oh, it actually saved 3 bits. That is, that's not what we want. So the problem is that the, no, that should not be the problem. That should be the solution. Fire it again. Let's see what happens. Did those bits go in? Yes, they did. So, but it's saved twice, so that means the system is actually firing double as long as it needs to be firing for some reason. Oh, because there's a repeater. Oh, that's my bad. So the reason why that's happening is because when you press the button, it's actually not what it's... You know, you don't need the extra repeater for the button, because that pulse extends it. So this should just be like that, and we're gonna start getting outputs now, but that's not what we want. Alright, now it's actually functioning as it's supposed to. These bits are now being saved, so we saved a 3-bit input, which also should have flipped... I'm thinking that might have flipped the... no, it didn't. Nothing flips this ever. This never ever gets flipped by the overflow. Oh no. But hopefully it will overflow at some point and that will happen, and you know, we could just switch it to logic now if we wanted to. So yeah, the computer is basically functional. All it needs is a full reset to actually get it to work again. But it should basically be functional. It's saving the data as it should mostly be saving it. Now this one hasn't been saved yet, but that's gonna be fine. They'll save when it switches next, so... So the way it knows when to switch over there and when to save data is when any number changes. So if a bit does not change between operations, then it's not gonna save that data. So that's why it's causing some issues over there. But that is, there's a fix for that, which is to detect when new data is being thrown in. So if you all have enjoyed today's episode of building a computer in Minecraft, please consider liking and subscribing. If you guys got any comments, questions, or suggestions, leave them down below. I'll see you all next time, and hopefully, you know, I actually put a world download for this, because this is actually pretty cool, so, yeah.